But if
Let
you're
me
not,
give you an example. I see a question now that says, how long does it take to make a solar panel? Okay, and that's a good question. Now, if I only had enough materials to make one solar cell at a time, it could take days to make a solar panel. But there are factories, mostly in China, that produce tens of thousands of solar cells per hour. And one panel may only have about 200 or 300 cells. And so you can imagine if you're making tens of thousands per hour, that means you can make a panel in just a few minutes. So certain factories out there make so many solar cells that you can make a panel in just a few minutes.
Was that Satellite Voyager I?
was that
I
a
have
picture
no
of
idea.
satellite? Oh.
I have no idea what satellite that was. That's just a generic picture of a satellite. But Mike is talking about the Voyager. Now, if nobody knows what the Voyager was a satellite that was launched into space in the 70s, and it's basically going away from the sun as fast as it can forever, which is kind of crazy, right? But I bet you Voyager had some solar. But it may have had some nuclear too, because that was a popular kind of energy at that time.
And needed to get out of Earth's atmosphere.
There was a question Danielle posted in the chat, which says, what happens when it's cloudy?
Okay, so I see that question. I apologize for skipping it. Solar will work in cloudy days. It won't be nearly as good as sunny days. If you have sun directly shining on a solar panel, it will produce the maximum amount of energy. But on a cloudy day, I'm going to guess probably 30 or 40% of the power can be generated. It's not quite as high, but it still can produce power. I see another question here. How hot is the sun? Now, that's a great question. And it's hard to answer because there are many layers of the sun. The core of the sun is a different temperature than the surface, which is a different temperature than just above the surface. I think I've heard that the surface of the sun is millions of degrees Fahrenheit. That doesn't make any sense, right? How can we even conceptualize what millions of degrees feels like? But put it this way, if you were to walk on the surface of the sun, you would instantly vaporize into a gas.
What are the different types of solar cells, solar panels rather? And
Okay.
would they be hot? Would the panels be hot?
Sure, so different types of panels. I spoke briefly about silicon, which is made out of the atom silicon, right? We basically take a lot of silicon atoms and make them into a crystal. And those crystals are then cut up into wafers, which then are made into solar cells. That's one type of solar cell. There are also thin film varieties that use other materials that are also able to make power. You can put panels on your roof. You can put them onto surfaces like calculators and other areas like that. It's really wherever power can be needed. Wherever power is needed, you can put the solar cell there. Panels themselves are usually made fairly similarly, where you have lots of solar cells stitched together to make more power. Really, the biggest differentiation comes in the materials that you use to make the solar cells. Silicon being one, the most popular. And I won't go into the other materials, but there are other thin film varieties where you can actually make a flexible panel, not just a rigid one. I'm going to go down the list here. Do you use solar panels yourself to save on energy, or what do you use for energy? So I have to admit that I rent. So I'm not able to put solar onto my roof. I suppose if I owned a home, I would seriously consider solar. The challenge, though, is solar is only now becoming competitive with traditional electricity generation. That means if I want to pay a bill for power, I can make a choice. I can pay this much for coal-fired power, or I can pay this much for solar. And only recently has solar become about the same as coal-fired electricity. So it's becoming more competitive for price. And if I had to choose solar, maybe I would now. About a few years ago, I probably wouldn't have, because I don't want to pay more for power. Why would I want to do that? But it's becoming less expensive. So let me see, looking down the list.
I saw Ava had a question. If Ava knows how to unmute herself, she can ask a question. Ava Johnson? Or I don't think we know. What about Jessa Parkman? I know your son had a question. I don't know if you can unmute him.
Perhaps while we're waiting for those, I'll try to answer some of these other questions here.
Go ahead.
Okay, so I see another one here that says, when was the first solar panel made? So I'll say the very first solar cell ever made was very, very poor efficiency, like 1 or 2%. Very, very bad solar cell was made in the 1950s. Oh, okay, I see someone might have a question.
Go ahead, Jessa.
Okay, ask your question.
What is a greenhouse gas?
A greenhouse gas, that's a great question. So traditional electricity sources burn coal or they burn oil. And when you burn something, it produces smoke, right? And that smoke has to go up into the air. And so that smoke contains gases like carbon dioxide and water, carbon monoxide. And so a greenhouse gas is a gas that goes up into our atmosphere and causes the heat of the sun to get trapped inside our atmosphere. Usually sunlight will come down and some of it will heat the earth and some of it will actually reflect back into space. But the more of these greenhouse gases that we put into the atmosphere, like carbon dioxide, less of the sunlight will get reflected back out. Now, a great example of a planet that suffers from the greenhouse effect is Venus. Does everybody know what Venus is? Venus is a planet that circles the sun, and it is super hot. It's like 900 degrees Fahrenheit because its atmosphere is mostly carbon dioxide. All of the heat from the sun gets trapped inside its atmosphere. It makes it super hot. Now, if we keep pumping CO2 into our atmosphere, it will cause our atmosphere to get hotter. And that's why we have a greenhouse effect. A greenhouse traps heat when you're growing plants. That's where we get that term from. Okay, so I'm going to move on to maybe another question.
Abby has a question.
Sorry. Is the sun hotter than lava?
I think so, yes. Lava comes out of the earth and it's basically liquid rock, right? Liquid rock might be a few thousand degrees Fahrenheit, which is still super hot, right? But like I said before, the surface of the sun is millions of degrees, millions, instead of just thousands. So certainly the sun is much hotter than lava.
I'm trying to unmute. Oh, I think Miss Garcia. Can we hear you now? Okay.
Go ahead, Sophie. What's the question?
Are the panels hot?
Okay, so our solar panel's hot. Now, when you stand in the sun, you feel heat, right? The heat that you feel is actually infrared light. It's light that's a little bit longer in wavelength than visible light. And so when you feel heat on your skin, that means that you're absorbing that light. Certainly solar panels, even though they don't use that light for making power, they absorb that light, right? And so yes, they get very hot. They can get up to 100 or 150 degrees Fahrenheit in direct sunlight. And that actually degrades the electricity production, but it's okay. We try to plan for that when we make the cells.
Okay, Miss Ashley Lowe had a question, or her son had a question.
Thank you. Okay, what do you want to ask?
Are there different types of solar panels?
Okay, so yes, there are different types. There are rigid panels that are made from wafer-based solar cells like silicon. There's also flexible solar panels that are made from thin films. Just to throw out some materials, I just recently stopped working at a company that used gallium and arsenic to produce solar panels that were very flexible and thin. There are other types of panels that use glass. There are some that uses metal. So there are lots of different form factors and types, but they all do the same thing. They all make electricity from the sun.
Okay, I think we have time for one more question.